Alright guys, we're going to do the F-test. We're going to keep it short, sweet, and simple. I'm not going to go into too much detail about it. We're just going to get it so that you can finish it up for the CSI final. Okay, so a couple things that I want to go over. Number one is that it is similar to the chi-square test. All right. We can use multiple means, and the cool thing is we can actually use standard deviation as a measure. All right. Try and zoom in again. I forgot. There we go. All right. Now, I gotta finish my notes. I forgot. We're still going to reject or failed reject our null hypothesis, and we'll be using our alternative hypothesis. We can go into a lot of detail about this stuff, but I'm only going to put on the notes and on the test and on the examples so that you can work on on Google Classroom. That's going to be similar to what CSI wants us to be able to do. All right. So even though we could do multiple means and standard deviations and that type of thing, we're only going to focus on a 2-sample F-test. Okay. All right. Now, what we still have our conditions. And of course, the first one's going to be random. How about I spell that, guys? Okay, random. You still have our 10% condition. And don't forget that, how did I put it? It may not be necessary. Because there was no sampling without replacement. All right. If you just want to go in and do the whole 10% of the population size, you can do that as well. It's just, I wanted to remind you from the chi-square test that we can do that. Okay. Our large counts, we're going to like this one. Doesn't matter the size. If it says that it's normal, we're good to go. So if the data set is a normal distribution, then you're safe to presume that large counts has been met. All right. If it doesn't say that it's normal, then n needs to be greater than 30, greater than or equal to 30. All right. And then on this one, the last one is, of course, if these two conditions haven't been met, we need to go for box plots. We need to check for strong skewedness and outliers. Okay. Where'd my eye go? Outliers. All right. So what we're going to do is we're going to do an example so you can kind of see it. What it's going to look like. Yeah, it'll be fun. I'm going to pause it so that we can not waste time. All right. To detect the presence of harmful insects in a farm field, we randomly place different colored poster board in the farm field. The poster board has sticky material to trap the insects. I forgot my sentence that says the resulting data is normally distributed. Anyway, give you a second on that one, and then we're going to go back to here. So then it says 6 blue boards were placed with a resulting standard deviation of 5.3448, and 6 green boards were placed as well with a resulting standard deviation of 6.3061. Is there significant evidence to show that the blue board has a greater attraction rate than the green board? Alright, so first thing we gotta do is we gotta make sure the conditions are met. Sorry. So first of all, it's random, and that's been stated. The 10% condition is not necessary. Because there was no sampling without replacement. So we got the random, we got the 10% condition, the large counts. Yeah, scoot that up. No sample without replacement. Large counts stated that the population distribution is normally distributed. Okay, so now what we're going to do is I have found it, working through this, that it's easier just to come up and kind of go S of x1, and that was my blue board, had a 5.3448. So I'm just going to come up here and say blue. The size of it was 6. And then I'm going to come up to here. I'm going to go green. S of x1 was 6.3061. Sorry, that should be S of x2. This is n2, and this was also 6. Okay. So then I'm going to go to my calculator. I'm going to go to tests, and then I'm going to move down to 2 sample F test. Alright, so I'm going to select that. Oh, looks like Mr. Nielsen already entered the data in. Yay! Oh, crap. Mr. Nielsen forgot to do the null hypothesis. So we know that the standard deviation of the population of x1 is going to be equal to the standard deviation of x2. Now, we can either do the alternative hypothesis. It could be standard deviation of x1 does not equal the standard deviation of x2, or we can start doing our inequalities. x1, x2, x1, x2. Okay, so we can do it like that. Either one of these is going to work, but for us we said greater than, that the blue is going to be greater than the green. So we're going to come to here, and I've already selected that. calculate it. So then what we want to report is my F critical score. Okay, so my F value is 0.7184. I want to report my p-value. I guess that should be a 3. All right. So then I've stated my null hypothesis, my alternative hypothesis. I've stated what test I'm using. Here's my F test. Here is my p-value. And so then I can go, well, that's bigger than 0.05. So that means I'm going to fail to reject null hypothesis. Okay, so then we would say there is convincing evidence that standard deviations of the population distribution color boards attracting insects are the same. Alright, so basically what we're saying is that there's not enough evidence, or there is convincing evidence that the standard deviations aren't wide enough or very enough to show that the blue board is more effective than the green board. So, that's basically what you're doing. So basically, if you can come up and if you can find this, right, state your hypothesis, and then we got to state our conditions. All right, and if you can put it into your calculator and just do that, you're good to go. That's all we're really going to be looking for. Okay? Alrighty, there's that one. That's it. One video. You're welcome.